Okay. So this morning, we are going to discuss the first chapter, which is all about the reactions in aqueous solution. By the way, can you see my presentation?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. Thank you. Okay, what do you understand about aqueous solution? If you would like to answer, you just click the hand button for you to be recognized. Yes, Leslie?
When we say aqueous solution, ma'am, it is a solution in which the solvent is always the water.
Okay, correct, no? Thank you, Leslie. Is there anybody who would like to share also what an aqueous solution is? Okay, wala na. So if we say aqueous solution, it is a solution in which the solvent is water.
What?
And virtually all three major categories of reactions that occur in aqueous solution. By the way, were you able to open your U-step?
Yes, ma'am.
Yes,
Access na ba tanan sa U-step?
Yes, ma'am.
Okay.
Dili ko ka-access, ma'am.
Dili pa
Good morning, yes,
kaka-access.
ma'am.
Okay. Sige. Ipalihog na lang kong email siguro sa DTO why you can't access U-step. I uploaded there the learning materials, videos from YouTube, which I believe very helpful, no? Very helpful in understanding the concept. And I also uploaded, I also posted there or check your understanding part. So siguro after 2 or 3 videos na I check your understanding of part wherein you are required to answer. Okay? So I have prepared there mga 3 siguro tong to 3 ka check your understanding. So please email na lang DTO. Okay, Karen?
Yes, ma'am.
Okay. So there are 3 major reactions that occur in aqueous solution. By the way, before discussing each of these 3 reactions, let me ask you first, what is a solution? So kaganina, we defined aqueous solution as a solution in which the solvent is water. No? How about a solution? What do you understand about a solution? What is your idea of the word solution? Yes, Glenda or Ma'am Glenda.
Good morning, Ma'am Faith.
Good morning.
My understanding regarding a solution, it is a homogeneous mixture of 2 or more substances.
Okay, correct. No, it is a homogeneous mixture consisting of 2 or more substances. Okay, any idea of what a solution is aside from the one given by Ma'am Glenda? What are the 2 components of a solution?
Solute and solvent,
Solute
ma'am.
and solvent.
Okay, thank you, Ma'am Janet and Sir Dan. They are solute and solvent. Okay. Now, what is the difference between a solute and a solvent?
When we say
Uh,
solute, it is the substance that being dissolved, while the solvent, it is the substance that dissolve.
Okay, the substance that is being dissolved is the solute, while the dissolving substance is the solvent. Okay, thank you for that answer, Sir Dan. Who else would like to answer? Kindly click lang the hand icon, no, for you to be recognized. Sige, who else would like to share his or her idea about the components, the difference between the two components of a solution? Sir Dennis. Yes, Sir Dennis.
Yes, good morning. Ma'am, solvent should always be the substance with the highest quantity, while
The
the other one,
solvent.
which is solute, which is
Okay.
said to be the dissolved substance.
Okay. So according to Sir Dennis, the solute is always present in smaller quantity, while the solvent is the one that is present in higher quantity. Yes, that is also correct, no? So the first definition given by Sir Dan, in which a solute is the one that is to be dissolved, while the solvent is the dissolving substance. I think that definition is true only for if a solution is composed of a solute, is composed of a solid substance and a liquid substance, no? Like for example, if you will mix salt and water, salt, which is solid, is the substance that is to be dissolved, while water is the dissolving substance. And for the definition of Sir Dennis, that is true also if our solute and solvent are both liquids or both solids or both gases, no? So like for example, if you have 70% isopropyl alcohol solution, in that solution, it is composed of isopropyl alcohol and water, okay? So since 70% isopropyl alcohol solution, so if you have 100 ml of the solution, 70 ml of that is isopropyl alcohol, okay? While 30 ml is water. So alcohol is present in greater quantity, therefore it is our solvent. And water, which is present in smaller quantity, so water is our solute. Now, if we have also a solution like ethyl, 30% ethyl alcohol solution. In 30% ethyl alcohol solution, our components, of course, are ethyl alcohol and water. If we have 100 ml of the solution, only 30 ml is ethyl alcohol and 70 ml is water. Therefore, our solute there is ethyl alcohol and water is our solvent. Okay, do you understand? Sige, let's continue. Okay, so a solution is a homogeneous mixture of two or more substances, which is composed of a solute, a component present in smaller amount or quantity, and another component, which is solvent present in larger quantity. So we have here examples of a solution like soft drinks. Water is our solvent, then sugar, carbon dioxide, and other substances mixed in the soft drink are considered as solute. Then our air is also a homogeneous mixture, no, is also a solution. And since nitrogen is the major component, no, in clean air, nitrogen is 78%, no, in air. And for other gases such as oxygen, it's about 21%. Carbon dioxide is 0.0, if I'm not mistaken, 0.03%, and trace amount of other gases. So since nitrogen is 78%, so dako kaayong nitrogen is our solvent. And the other gases such as oxygen, argon, methane, carbon dioxide, water vapor, all of these are considered as solute. Okay. We have the soft solder. Our solvent there is lead, and the solute is tin. Okay, so a solution could not only be formed between a solid and a liquid, but it can also be formed between a solid and a solid, or a gas and a gas, or a liquid and a liquid. Okay. Now, when a substance is dissolved in water, and then after dissolving that substance in water, it will result to a solution that can conduct electricity. The substance is said to be an electrolyte. But if a substance dissolved in water and will result in a solution that does not conduct electricity, the substance is said to be a non-electrolyte. Okay, so an electrolyte is not the solution itself, but it is the substance that is dissolved in water. And after dissolving that substance, will result to a solution that can conduct electricity. The substance itself is what we call an electrolyte. No? So if the substance that is not when dissolved in water and results to a solution that cannot conduct electricity, the substance is considered as a non-electrolyte. Okay. So if we're going to compare the substance or a non-electrolytic substance, a weak electrolyte, a substance that is a weak electrolyte, and a substance that is a strong electrolyte, no? Kung ato silang i-compare using this glow of the light bulb, for the non-electrolyte, this light bulb will not produce light. Okay, when these electrodes are immersed into the solution containing a non-electrolyte substance. If the substance is a weak electrolyte, it produces, when it is dissolved in water, it will produce small amount of ions, and so the light bulb will still glow, but it is dimly lit, no? Because only few ions are produced, only few ions are being produced in the solution for a weak electrolyte. But for a strong electrolyte, okay, the light bulb here is brightly lit, no? Because it contains large. Okay. So when a substance is dissolved in water, no, and if it is let's say an ionic compound like sodium chloride, it will produce ions, no? It will produce ions such as cations and anions. So in the case of sodium chloride, it will dissociate into ions, producing sodium ion, which is a cation, and chloride ion, which is an anion. Okay. So for strong electrolyte, the dissociation of the substance is 100%. So what does it mean? So like sodium chloride, kung ato na siyang i-dissolve sa water, it will produce, there is complete dissociation. So the cation, which is sodium ion, will be completely separated from the chloride ion, which is our anion. Okay, that is what we mean by 100% dissociation. Okay, so in the solution, you can no longer find sodium chloride, no, in the solution, but you can find there aqueous sodium ions and aqueous chloride ions. And for weak electrolyte, the dissociation, although there is dissociation, but it is not complete. Okay, only few of the particle is dissociated. Okay, maybe some particles also dissociate into ions, but after some time, mabalik ra gihapon sila, mobond ra gihapon. So there is incomplete dissociation. Okay, like for example, the acetic acid. Acetic acid is a weak acid. And if this is mixed with water, the acetic acid will produce acetate ion, CH3COO negative. So it will produce acetate ion and hydrogen ion. But after some time, some of these ions will bond again to form back the acetic acid. That's why, as you can see, there is there are two arrows in different direction. Kay in the forward reaction, this is the arrow pointing to the products, and in the backward reaction, this is the arrow pointing the original reactant. Okay, so there is incomplete dissociation. Okay, so in the solution, you can find aqueous acetate ions and aqueous hydrogen ions, and also the molecule acetic acid. Because, as what I have said, after some time, they will bond again to form back the original substance. So it's a weak electrolyte. Okay. So solid sodium chloride, which is an ionic compound, breaks up into sodium ions and chloride ions when it dissolves in water. And the sodium ions are attracted to the negative electrode, and the chloride ions are also attracted to the positive electrode. And this movement sets up an electric current that is equivalent to the flow of electrons along a metal wire. So this explains the illustration that I presented to you a while ago. This one, no? That is the explanation why this light bulb glows brightly. Okay. Okay, so For weak electrolyte, the reaction in aqueous solution is a reversible reaction. So that's why these two arrows in opposite direction means reversible reaction, which means that the reaction can occur in both directions. Okay. So the ionization or the dissociation of acetic acid in water is incomplete. That's why it is a weak electrolyte. But for sodium chloride, the dissociation is 100%, no? 100%, and there is no chance of bonding these ions together. Okay, because the dissociation is complete. So that's why a sodium chloride, which is a strong electrolyte, is considered a strong electrolyte because the dissociation is complete. Okay. Now, what happened during the dissociation of ions in water? So this we call this there is what we call a process called hydration, no? Hydration, and it is a process in which an ion is surrounded by water molecules arranged in specific manner. Okay. So, when a strong electrolyte like sodium chloride is dissociated, as what I have said, there is complete dissociation, no? So, nganong lesser or nganong there is no chance man of why is it nga there is no chance of bonding together these two ions? It's because of the process called hydration. Okay. Now in hydration process, di ba sa water molecule, if okay, imagine this as water molecules. In a molecule of water, there is one atom of oxygen, and this red colored ball represents our oxygen. Okay. And this white colored ball, or is this gray? I think gray colored ball is also representing our hydrogen atom. So since there are two white colored balls, meaning there are two atoms of hydrogen bonded to one atom of oxygen, no, in a water molecule. Now, what happened during hydration is that during hydration, di ba, si oxygen, this is partially negative, okay? The hydrogen atom is partially positive, partially negative, I'm sorry. Wait, the hydrogen atom is partially negative, while the hydrogen atom is partially positive. Nganong partially positive man si oxygen and nganong partially negative si oxygen and partially positive si hydrogen? Okay. If we will go back to periodic properties, one of the periodic properties is electronegativity, no? In a molecule like water, diba, oxygen has already 8 electrons. Okay? Si oxygen na siya 8 electrons, while hydrogen has only 1 electron. Now, si oxygen, na siya 8 electrons, pero napagyapon siya hunger. Napagyapon siya hunger for electrons. It has already 8 electrons, pero gabirahon pagid niya ang electron ni oxygen, ni hydrogen. Because of that, ang electron ni hydrogen will be pulled by oxygen, so oxygen becomes partially negative. Si hydrogen, since its electron is also pulled by oxygen, so hydrogen becomes partially positive. Okay? Partially positive kay si proton di man na mabira ni oxygen kay proton is inside the nucleus. So, ang electron ra ni hydrogen mo igabirahon ni oxygen, no? Si oxygen, it has plenty of electrons already, but napay try hunger for electrons, no? So, birahon niya ang electron ni hydrogen. That's the reason why hydrogen becomes partially positive while oxygen becomes partially negative. Okay? So that happens in a molecule, no? That happens in a molecule. And because of that, since oxygen becomes partially negative, oxygen is attracted to the cation. So in this case, we consider sodium chloride as our strong electrolyte, which is dissolved in water. So oxygen is attracted to the cation, which is the sodium ion. That's why, and our chloride ion here is the hydrogen, these two hydrogens in every molecule are also partially positive, no? They are also partially positive. So since they are partially positive, they are also attracted to the anion. So in this example, our anion is the chloride ion. Do you understand? Hello?
Yes, ma'am.
Sabtan ko ninyo?
Yes po.
Okay, so as you can see, the orientation of the water molecules here is different from the orientation of the water molecules here. Tanawa, ang oxygen mo ay na-attract sa, ang mga oxygen atom mo ay na-attract sa cation, while the hydrogen ions are attracted toward the anion. Okay? So this process in which water molecules are attracted to the anion and other water molecules also are attracted to the cation, we call this process as hydration. And because of that, each ion, cation and an ion, each ion is surrounded by water molecules. There is no chance of bonding these two ions again. Okay? That is what we mean by complete dissociation. I hope you understand. Okay. Now for non-electrolytes, as what I have said earlier, they do not conduct electricity, no? They do not conduct electricity because no ions are formed. There are no cations and no anions. Like for example, C6H12O6, when this is dissolved in water, this is sugar, no? When sugar is dissolved in water, it will be dissolved in water, but in the solution, you cannot find ions, but only water, only sugar, no? Sugar molecules, aqueous sugar molecule. Okay? So, nakuan lang sila, napino lang, turned into very, very fine particles, but still sugar. No dissociation of ions. Okay. So in this table, we have here the strong electrolytes. Examples of strong electrolytes are hydrochloric acid, nitric acid, perchloric acid. We have the sulfuric acid, sodium hydroxide, barium hydroxide, and ionic compounds. Now, this hydrochloric acid, nitric acid, perchloric acid, and sulfuric acid, all of these are examples of strong acids. Sodium hydroxide, barium hydroxide, these two also are examples of strong bases. Then we have the ionic compounds. So the strong electrolytes, we can say that the strong electrolytes are the strong acids, the strong bases, and ionic compounds. All of those are strong electrolytes. No? When they are dissolved in water, they will ionize completely, forming ions. For the weak electrolytes, usually the weak electrolytes are the weak acids and weak bases. So weak acids such as acetic acid, hydrofluoric acid, nitrous acid. And for the weak base, an example of a weak base is ammonia, NH3. And water also is considered a weak electrolyte. For the non-electrolyte substances, we have urea, methanol, ethanol, glucose, sucrose, no? Mga molecular compounds or covalent compounds are non-electrolytes because they have no ions, right? Wala man sila'y ions, no? So molecular compounds or covalent compounds are non-electrolytes. Okay. So sa akong giingon ganina, there are types of reaction which occur in chemical solution or in which occur in aqueous solution. Okay, we have the precipitation reaction, the acid-base reaction, and acid-base neutralization reaction. And also there are 4 also the oxidation reduction reaction. Okay. Now, before we start with precipitation reaction, are there questions or clarifications regarding electrolytes, non-electrolytes, and weak electrolytes?
None so far, ma'am.
Okay, thank you. So let's go to precipitation reaction, which is one of the types of reaction that can occur in an aqueous reaction, no? Aqueous solution rather. So a precipitation reaction results in the formation of an insoluble product or precipitate. What do you mean by the word insoluble?
Cannot be dissolved. Cannot dissolve.
Okay, thank you, Ma'am Felmi. Insoluble means cannot be dissolved, no? So this precipitation reaction results in the formation of an insoluble product. This insoluble product is called precipitate. In other words, it will result to the formation of a solid substance, no? Like nakay duha ka solutions, diba? Kung duha ka solutions, imong i-mix together. Nga mix nila mo produce og a solid substance or insoluble substance, which we call as precipitate. Okay? And usually, precipitation reaction involves ionic compounds. So the precipitate is the insoluble solid that separates from the solution. Like for example, if you have aqueous lead 2 nitrate react with aqueous sodium iodide. Now, you might be asking, ma'am, anong may makag-aqueous? Aqueous because this is already a solution. Okay, dili man ni siya solid. This is already dissolved in water. So we call it aqueous lead 2 nitrate. And this one is aqueous sodium iodide. So these two solutions are allowed to react together by mixing. And after mixing, they produce a solid substance. In this reaction, the solid substance that is formed is lead 2 iodide. And as you can see, the subscript is S, which means that it is solid. Therefore, this is our precipitate. Okay. And another product is the sodium nitrate. Aqueous sodium nitrate, na ay subscript nga AQ, because sodium nitrate here is part of the solution. You understand? Okay, so kini si lead 2 iodide is not part of the solution. Okay, it is separated from the solution, so it is solid. Now, the other product, which is sodium nitrate, is part of the solution. That's why its subscript is AQ. Okay, so we call this equation as molecular equation. Now, in writing the molecular equation, we need to balance, no? Isulat nato ang mga substances involved in the reaction. So, i-identify nato ang sa atong mga reactants and the products, no? And also their state, aqueous ba sila or solid state ba? Then after, we need to balance, okay? We need to balance them. So in this example, this is already balanced. So we have 1 mole of aqueous lead 2 nitrate, 2 moles of aqueous sodium iodide react together to produce 1 mole of solid lead 2 iodide and 2 moles of aqueous sodium nitrate. Okay, so in this case, this equation is already balanced and we call this as molecular equation. Now, after writing the molecular equation, we need to ionize them. Kay aqueous man sila, meaning na-dissolve man sila sa water. So, atos lang i-ionize. Okay? Like, in lead 2 nitrate, kung ato ni siyang i-ionize, okay, tanawa, you look at the subscript of nitrate. The subscript of nitrate is 2, which means that this 2 here is the oxidation state of lead, no? Mo na siyang oxidation state ni lead. So, mo na nga, in writing the ion of lead 2 ion, we have Pb plus 2. The subscript of lead here is 1. 1 ang subscript. Diba? So remember mo sa crisscross method? Diba? Crisscross method. The subscript of the cation is the charge, the magnitude of the charge of the anion. The subscript of the anion is the magnitude of the charge of the cation. So, saan lang magnitude? Mo na siya ang value sa iyang charge, no? Like here in lead, the subscript of the anion, our anion is nitrate. The subscript of nitrate is 2. So, mo ni siya ang value sa ang value that this is the magnitude of the charge of lead. Did you get it?
Yes, ma'am. Or
Okay.
in other words, the oxidation state of the
Correct. Exactly, no? So, the magnitude of the charge or the magnitude of the charge, meaning the oxidation state of lead. Okay, so lead plus 2. Kini 1 man, so mo ni siya ang magnitude sa charge pod ni nitrate. So mana -1. So you might be asking, ma'am, nganong na ay 2 dinha as the coefficient of nitrate? It's because there are 2 in the molecule, or in this substance, there are 2 moles. The subscript of nitrate is 2. So meaning there are 2 moles of nitrate. Si lead, the subscript of lead is 1. So ang iyang coefficient is 1. Okay? Now, for sodium iodide. Okay, the subscript of sodium is 1, which means that the magnitude of the charge of iodine is 1. Unya kay kuan man siya, non-metal man ni si iodine. So mana -1. Okay? So -1 si iodine. The magnitude the subscript of iodine is also 1, which means it is the magnitude of the charge of sodium. So si sodium kay metal man, so mana nga +1. So our sodium ion is Na+, and our iodide ion is I-. Pero nganong 2, na ay 2 din ha, na ay 2 diri, which means that 2 times 1, the subscript of sodium is 1, so 2 times 1, so there are 2 moles of sodium ion. The subscript of iodine is also 1, so 2 times 1, so there are 2 moles of iodide ion. Okay? Am I understood?
Yes po.
Okay.
Yes, ma'am.
I hope, ako na ay pangutana na ay dili masabtan, basig, panra, dili ra klaro nga pagka-explain na ako, no? You are free to ask. So, since our lead 2 iodide is solid, so it cannot be dissociated into ions. So let us just write lead 2 iodide as it is. Okay, solid man siya. So we will write lead 2 iodide. Okay, there is no dissociation of lead 2 iodide. It is solid. For sodium nitrate, okay, pareho ra gyapon nga paagi kung giyon sa nato sila pagsulat. So atong gipa-ionize or gi-separate nato sila into ions. So we have 2 moles of sodium ion and 2 moles of nitrate ion. Okay, so this is how to write the ionic equation. Okay, now in this ionic equation, there are ions which are considered as spectator ions. Okay, and these spectator ions can be found in both sides of the reaction. Like for example, si sodium ion naa siya sa reactant side, apoy sodium ion in the product side. So kini pod si nitrate ion naa sa reactant side. There are also 2 moles of nitrate ions on the product side. So we can cancel these 2 ions. Okay, so we call these 2 ions as spectator ions. Okay, and then let us write what is left after the cancellation of the spectator ions. So ang mga ions nga nabilin are, we have lead 2 iodide and 1 mole of lead 2 iodide and 2 moles, 1 mole of lead 2 ions, 1 mole of lead 2 ion, and 2 moles of iodide ion. Okay, then sa ato ang product nga nabilin, we have the lead 2 iodide, which is a solid. Now, kung atong hunahunahon, kung tan-awon nato ang mga substances nga nabilin on the left side and the right side, there is kanang, our answer is reasonable, no? Nganong nakaingon man ta nga reasonable? Because the lead 2 iodide, which is considered here as our product, is formed by, or is formed between lead 2 ion and iodide ion. So if ever mahibaw-an nato nga ay mali ang atong net ionic equation kung ang atong gisulat diri is sodium ion. Sodium ion, 2 moles of sodium ion. Unya wala ning niya siya. No, 2 moles of sodium ion plus 2 moles of iodide ion. Ang atong product is lead to ion. How come na form si lead to ion nga wala may lead sa ato ang reactant ang naa is sodium ion? In that case, we can say that our net ionic equation is wrong. Okay, so take note that we need to cancel out the spectator ions. These ions, the spectator ions, can be found in both sides of the reaction. Okay? Do you understand?
Yes, ma'am.
Okay. Okay, so if we say molecular equation, it is an equation where the formulas of the compounds are written as though all species existed as molecules or whole units. So wala na to gi-ionize. We write we write all the substances involved in the reaction as they are. No, we write them as molecules. For ionic equation, it shows dissolved species as free ions. So we are writing those ions forming the compound. Okay, mato ato ang gibulag si lead to ion, lead to iodide atong gibulag. So, okay, we are writing the ionic equation. So sa ionic equation, makita nimo the dissolved species as free ions. Okay? So since si lead to iodide is our precipitate, it cannot be dissociated into ions. Then the net ionic equation shows only the species that actually take part in the reaction. So this is the equation that is formed, or that this is the equation na which results after the cancellation of our spectator ions. Okay. You understand, class?
Yes po.
Okay, so this is how the formation of yellow precipitate, no, the lead to iodide as a solution of lead to nitrate is added to a solution of potassium iodide. Okay, this is now the net ionic equation. Okay, so another idea that we need to, that is very important for us to know if a substance is soluble in water or not soluble in water is we have to know whether the substance is soluble or not soluble. No? So it has something to do with the solubility of that substance. So may solubility, that is the maximum amount of solute that will dissolve in a given quantity of solvent at a specific temperature. So there are solubility rules for common ionic compounds in water at 25 degrees Celsius. So what are these soluble compounds? Okay. So it is said here that compounds containing alkali metal ions. So kinsa man ning mga alkali metal ions? Diba these are the metals found in the first column, no? First column in the periodic table. Yes, correct. The group 1 elements, no? When they form ions, we call them as alkali metal ions. Like for example, we have the lithium ion, sodium ion, potassium ion, rubidium ion, cesium ion, and also the ammonium ion. So all compounds containing these ions, metal ions, alkali metal ions, and ammonium ion are considered soluble compounds. What do you notice? If a compound is containing these alkali metals, unsa may tawag nato ana nga compound? If a compound is containing a metal, unsa may tawag nato ana nga compound?
Compound, ionic compound.
Correct. Okay, it is called ionic compound. Di ba sa akong giingon ganina, one of the strong electrolytes are the ionic compounds, no? So, di ba nag-mention ko ganina, the strong electrolytes are the strong acids, the strong bases, and ionic compounds. Sila ang mga strong electrolytes. And sa atong definition a while ago, strong electrolytes are those substances that when dissolved in water will dissociate. Those substances, strong electrolytes are electrolytes that when dissolved in water will result to a solution that can conduct electricity, di ba? So nganong makakonduct sila electricity? Because they form ions when dissolved in water. Okay? So kining mga ionic compounds, specially formed by the alkali metal ions, will dissociate completely in water. So meaning they are soluble. Okay? They are soluble. And aside from that, also compounds containing ammonium ions. Okay, NH4+. Nitrates, carbonates, and chlorates are also soluble in water. Okay. Then we have the halides, meaning these are the ions of the elements, ions formed from the elements belonging to the group 7A or the halogens, no? Ang mga halogens, elements in the halogen group, if they form into ions, they are called halides, no? So we have, what are these halides? We have the chloride ion, bromide ion, iodide ion. Okay, these halides are soluble compounds except when they form a compound with the silver ion. Maparisan nga ni silang silver ion, mahimo na silang insoluble. Or maparisan silang mercury 1, okay, maparisan silang mercury 1 ion, they become insoluble, and also lead 2 ion. Sulfates also are soluble, no? Sulfate ions. They are also soluble except if they bond with silver ion, calcium ion, strontium ion, barium ion, mercury 1 ion, and lead 2 ion. Okay. Now, if there are soluble compounds, there are also insoluble compounds. So we have the insoluble compounds are compounds containing carbonates, phosphates, chromates, no, sulfides. But not all compounds containing these ions are insoluble. If these ions will bond with alkali metal ions and ammonium ion, these compounds containing carbonates, phosphates, chromates, and sulfides become soluble. So naagya pa exception, no? Pero kung kini sila maparisan og other substances, no, other than alkali and ammonium ions, mahimo sila insoluble gid sila kung maparisan sila lain. But if they will be bonded to ions of alkali metals and ammonium ion, they become soluble. Okay. Hydroxides are also insoluble except when bonded with alkali metal ions and a barium ion. Okay, like for example, sodium hydroxide. Sodium is an alkali metal, no? So, kung calcium hydroxide, it is insoluble. Okay, calcium is not part of the exception. Pero, kung muband siya with sodium, forming sodium hydroxide, okay, so this ion becomes soluble because it is bonded with an alkali metal, which is sodium, forming the sodium hydroxide. Okay, do you understand?
Yes po.
Okay, let's continue. Sige. You try to answer this. Sige.
For letter A, silver sulfate is insoluble po.
Silver sulfate is
Insoluble po.
insoluble.
Insoluble.
Okay, insoluble ba?
Yes po.
Silver.
So I have here 4 names. So mag-react tayo ha. So first reading nas manakpakan.
Okay, silver sulfate is soluble or insoluble? What is your answer?
Insoluble.
Okay, correct. Insoluble. Si sulfates, kung maparisan siya glain nga metal, soluble ba siya or not?
Yes, like for example, sodium sulfate. It's soluble.
Okay. So soluble unta siya. But since naparisan siya og silver, so
Cannot
nahimo
be.
siyang insoluble. Correct. How about number 2?
Calcium carbonate is
Yes.
insoluble po.
Soluble, ma'am.
Okay. Wait. Insoluble also, no?
Yes
Ano
po.
man?
Yes.
Carbonates are
Soluble.
insoluble yun si carbonates. O niya, kay naparisan pa yun siya ni calcium, nga, which is not part of the exception, so it remains insoluble. Okay. How about letter C?
Soluble, ma'am.
Soluble.
Why soluble?
Sodium is alkaline.
Sodium, si phosphate, di ba phosphates
Yes,
are
insoluble.
insoluble?
Yes.
Phosphates are
because of sodium.
insoluble via, but because of sodium, sodium is an alkaline metal, no?
Metal.
Alkaline metal. Okay, so nahimo siyang soluble. Okay, how about letter D?
Soluble.
Copper 2 sulfide is
Insoluble.
why insoluble? Nganong insoluble man?
Copper.
Sulfide is already
Is it because of copper?
No.
Sulfide is already
insoluble.
Sulfide is already insoluble.
Insoluble.
Correct. So, naparisan pa yun siya ni copper. So, insoluble. How about calcium hydroxide?
Insoluble.
Insoluble.
Diba na to'y exceptions? Si hydroxide insoluble man yun siya. Naman to'y exceptions. Appeal ba si calcium sa exceptions?
No. Only
No.
barium in the 2.
Okay, only barium in
only
group 2, no?
Ammonia.
And metal and the alkali metal ions. So, calcium hydroxide is insoluble. Very good. How about number 3? Nitrates, zinc
Soluble.
nitrate.
Soluble.
Okay, it is soluble. Nitrates are soluble, no? So wala may exception sa nitrate. So any compound formed by nitrate ion and a metal ion, no, are soluble compounds. Okay, very good. Thank you for your participation. Okay, let's go to writing net ionic equations. So in writing the net ionic equations, we have to write first the balanced molecular equation, and then Write the ionic equation showing the strong electrolytes completely dissociated into cations and anions. Then cancel the spectator ions on both sides of the equation. Check the charges and number of atoms. Check if the charges and number of atoms are balanced in a net ionic equation. Okay, so for example, write the net ionic equation for the reaction of silver nitrate with sodium chloride. Silver nitrate and sodium chloride. So what's the formula of silver nitrate?
AgNO3, ma'am.
Okay, AgNO3. Dayon, sodium chloride,
NaCl.
NaCl. Okay. So this is now our molecular equation. So do not forget to write the physical state, no? So we have aqueous silver nitrate reacts with aqueous sodium chloride, producing silver chloride, solid silver chloride, and aqueous sodium nitrate. Okay, so is the molecular equation already balanced?
Yes.
Okay, be balance na ba?
Yes, po.
Balance na, no?
Mm.
Okay,
Mm-mm.
then after balancing, let us ionize the our aqueous solution. Atong i-ionize. So kinsa man yung mga aqueous solution? Silver nitrate, sodium chloride, and sodium nitrate. So, ganong sila raman ang atong i-ionize? Because silver chloride is a solid, no? Dili siya ma-ionize. Okay, so these are the ions forming the aqueous solutions. So we have silver ion plus nitrate ion plus sodium ion plus chloride ion. These are the ions in the reactants. And for the products, we have sodium ion and nitrate ions. Okay, cancel our spectator ions. Then we have sodium and nitrate ions as our spectator ions. Then you write what is left. So ang nabilin, silver ion plus chloride ion forming silver chloride. Okay, so this is now our net ionic equation. The second equation is our ionic equation. The first equation is our molecular equation. The third one is our net ionic equation. Okay? Sige. How about this one? Water ka dyan, ha? Sige. Hello?
Yes, po, ma'am.
Sige. Can you answer this? Potassium phosphate is mixed with calcium nitrate. Then the other one is a mixture of aluminum nitrate and sodium hydroxide. Sige, you try daw. Sige, mana? Ay, wait. Chat lang ha. Kaya nawala ako ang connection. Ay. Join. 970 3891 1429. 409 451. Ako, gadget lang ha. Pwede ako saning i-stop share. Yes, Ma'am Glenda, are you raising your hand? Pwede ako sa
Yes,
i-stop
ma'am,
share
for-
ka, Jud?
Yes, ma'am.
Okay. Sige. So, do you want to answer, Ma'am Glenda?
Yes, ma'am, but I don't know how to share screen. So ako na lang isulat sa papel ko. So, I'm sure na akong mga kauban mo na po sila answer. So I'll just
Sige, I think you can write. Are you using a laptop or cell phone?
easy, ma'am.
Maka-write man siguro mo.
Sa
I-try daw. Oo, naka-write ka. Sige. Sige daw, Ma'am Glenda. You write first the molecular equation. Sige. Sige, you better dictate na lang. I will be the one to write.
Okay, so for the molecular equation, so we have there two potassium. So,
Okay.
so that's,
What's this? You say it correctly, no? Say the equation correctly.
2 atom of potassium. Sige, ma'am.
Atom ba
Okay,
na?
so-
Sige, you should know this, no? Kanang unsaon na to pagbasa sa equation? So kanang 2 din ha. That means 2 moles.
2 moles.
Moles.
Okay, so 2
So,
moles of
2
potassium.
moles of, okay, na-AQ nga subscript. So how are we going to name that one? That is 2 moles of aqueous potassium phosphate.
Okay.
Okay,
So 2
so
moles of aqueous solution of phosphate.
pwede na walang solution. Aqueous potassium phosphate.
Potassium of phosphate.
Aqueous
reacts
potassium
with-
phosphate. So that's K3PO4 AQ. Diba? Can you see what I wrote?
Yes,
Yes,
ma'am.
ma'am.
Okay. Plus,
Reacts
what's the other
with-
reactant?
It reacts with
Okay.
1 mole of
1 mole. Are you going to give na the balanced molecular
calcium,
equation?
aqueous calcium of nitrate.
So how many moles of
Ay, sura di ko
aqueous
basa.
calcium nitrate? 3 moles.
P.
Kanang mga coefficient, mga na sila, moles na sila. So 3 moles of aqueous calcium nitrate. Sometimes if you will not give correctly the kanang unsa na mga numbers bitaw sa atong klase. Oo, kada sa klase nato mahatag ang insakto nga description for those numbers.
So the coefficient
Those would create misconception sa atong mga students. So it is very important that we ourselves, no, as teachers, we should know how to read them correctly. No? Kay ang atong mga estudyante maglibog pud. Dili pa na atom, nganong hiingon man si ma'am nga atom. Kay kung atom, isa ra gyud na siya nga element. Di ba? So, sige. Dayon, unsa may mga atong mga products?
yields with the product of 2 moles of potassium, aqueous potassium of nitrate.
O wala na ng of potassium nitrate, not
Ah.
potassium of nitrate. Kay compound man sila.
2 moles
So that's
of
potassium
aqueous
nitrate.
potassium nitrate.
So how many moles of aqueous potassium nitrate?
2 moles, ma'am.
2 moles. Sige, let's see kung balance ba.
Sakto ba?
Sige, isulat sa nako. 2 moles according to Ma'am Glenda. 2 moles of potassium, aqueous potassium nitrate. Okay. Plus, what's the other one?
And calcium phosphate, solid ma'am.
Okay, how many moles of solid calcium phosphate?
Like something wrong sa ako ang equation. Just 1 mole.
1 mole?
No.
Sige, 1 mole of solid calcium phosphate. Wait. This is 4. Okay, please try to check if the equation is balanced. Dili lang kay si Ma'am Glenda, no? Ang uban pod. Kindly check kung balance ba. How many atoms of potassium? This is 2 times 3, that's 6.
It's supposed to be
so-
6.
So potassium, phosphorus, oxygen,
6 po,
calcium, nitrogen. Okay. So on the reactant side, 2 times 3, that's 6. Sa product side, there's only 2.
6 po dapat.
So dapat 6. So sa may atong ipuli dire.
6 sa product.
Okay, 6, correct. So this is also 6. Potassium, 2 times 1, this is 2. Sa product, 1 times 2, 2. Oxygen, this is 2 times 4, is 8. 8 oxygen, plus this is 3. Kini, 3 times 2 equals 6. 6 times 3 equals 18. So 18 plus 8, pila man na? This is 26. Diba?
Yes,
Sige
ma'am.
po, 3 times 6 is 18. And then 4
Two
times 2 equals 8. 8 plus 18 equals 26. For nitrogen, for calcium, this is 3.
3.
On the other side, 3 also. Our nitrogen, this is 3 times 2 equals 6 times 3 equals 18. Dere?
6
Ay,
times
Ay, wait. Kuma naman dito sa oxygen. Sorry. Dire na to sa nitrogen. This is 1 times 3 equals 3. Ay, wait. 1, kay subscript niya, 1. Times 2, na may 2 sa kuan.
Lawas.
So 2 times 3 equals
Parang ma'am.
6. Okay, this is 6. Here, subscript of nitrogen is 1 times 6. This is 6. Okay. So, our balanced equation. Isa ni-erase. Okay. So, our balanced equation, this is the correct way of reading, no, the molecular equation. So kindly listen, no, kay para malikayan ang confusion sa mga estudyante. So this is 2 moles of aqueous potassium phosphate react with 3 moles of aqueous calcium nitrate to produce 6 moles of aqueous potassium nitrate and 1 mole of solid calcium phosphate. Okay, so kining mga coefficients nato, ang tawag nato ana nila moles. Okay. Okay. Then how about our ionic equation? How about the ionic equation? Sige, kung atong i-ionize, what is our cation here? There is a first, our cation is potassium ion. Okay, so part man siya sa solution, so we are going to write AQ. Okay, plus our anion is PO4 negative 3 or the phosphate ion. Part siya sa equation, we also write AQ. So, unya na ta mag-balance ha, para dili ta maglibog. Sahaw na natog balance. Dayon, in this compound, our cation is, we have the calcium ion, Ca plus 2, plus our anion is NO3 negative 1. Part sila sa equation, so we are going to write AQ. Okay. For our products, this one is also an equation, and our cation here is potassium ion and nitrate ion. Oh, wait. An ion man, so dapat this is negative. Okay. Plus our precipitate. So we have Ca3PO4 2. Pwede man nato ma-ionize si precipitate kay it is solid. Okay. Now, let us balance our equation. When you look at the balanced molecular equation, there are 2 moles of potassium. So, pero ang iyang subscript is 3. No? So, 2 times 3. So, pila man na siya. So, meaning there are 6. Okay? 3 atoms of potassium sa isa ka mole. Unya kay 2 moles man. So, ito i-multiply. So, 3 times 2 equals 6. So, 6 moles of potassium ion. Ang atong phosphate, kining 4 kay subscript man na siya sa oxygen. Dili man na siya subscript sa the whole polyatomic ion nga phosphate ion. Ang iyahang subscript is walay gibutang, so understood nga 1. 1 times 2 kay 2 moles of potassium phosphate. So this is 2. Okay? Now si calcium ion, pila iyang subscript? 1. So in this compound, 1 mole of calcium nitrate, isa lang ka-atom sa potassium, sa calcium. But there are 3 moles man. So 3 times 1 equals 3. Okay? Then our nitrate, tanawa, nakasulod sa parenthesis ang atong nitrate ion with a subscript 2. So meaning, in 1 mole of calcium nitrate, there are 2 moles of nitrate ions. Unya kay 3 moles of calcium nitrate man. So 2 times 3 equals 6. Okay. Then for potassium, the subscript of potassium in potassium nitrate is 1. So kung isa lang ka mole of potassium nitrate, in 1 mole of potassium nitrate, 1 atom lang sa potassium. But since there are 6 moles, so 6 times 1 equals 6. Kung 1 mole of potassium nitrate, there is only 1 mole of nitrate ions also. But since there are 6 moles of potassium nitrate, so 6 times 1 is 6. Did you get me?
Yes, ma'am.
Okay. Kung di mo ka-follow,
ma'am.
you ask, ha?
Yes, ma'am.
Okay. So, kini siya. Sakto na na siya. So, let us see if our equation is balanced. 6 atoms of potassium ion, 2 atoms of phosphorus. This is 2. Oxygen, 4 plus 18. 2 times 8 is, 2 times 4 is 8. Plus 18, that's 26. Dari 18 plus 8, 26. Si calcium, this is 3. 3. Nitrogen, 6. 6. Okay, so our ionic equation is already balanced. And then, cancel out the spectator ions. So, cancel. Sa pa yung makancel? Nitrates, cancel.
NO3,
Cancel. Okay. So, ang nabilin, tingin na lang, potassium ion and calcium ion. Now, ang atong iunag sulat is the cation. Do not start writing with the anion. So, our cation is calcium ion. So, 3 moles of calcium ion plus 2 moles of aqueous phosphate ion yield 1 mole of pwede din na nato isulat ang 1.
Calcium
1 mole of solid calcium
ion.
phosphate. Dili ion si calcium phosphate. Okay, kuan mo siya? Solid man siya. This is our precipitate. So this is our net ionic equation. This is our ionic equation. And this one is our molecular equation. Okay.
Thank you, ma'am.
Okay. Now let's proceed to problem number 2. Wala, sorry. Ako nang gi-turn sa next page. Okay. Kana. Gusto niyo mo copy? Screenshot na lang para di ta malangan.
Yes, ma'am.
Okay. So, ato to sa next number, no? Sige. Wait, ha? Okay. Number 2 is predict the precipitate produced by mixing aluminum nitrate solution with sodium hydroxide solution. Okay, so importante gid kaayo makabalota mo sulat sa formulas, no? Okay, what if ang ihatag lang is the name of the compound, no? Nya di ta kabalo saan pagsulat correctly sa formula. So marong na gyud ta diretso, no? Di na ta kung sa ato ang pag-start pa lang pagsulat pa lang nato sa equation wrong na ang atong formula, marong na gyud na tanan, no? Okay, so importante kaayo na kabalot ta mo name correctly and write correctly the formulas. So we have aluminum nitrate Al NO3. Okay. This is a solution, which means that we're going to write AQ. Okay.
AQ.
Plus NaOH. Solution gihapon. So we are going to write
Aqueous.
AQ. Yes. So what do you think are our products? Wa sa ta nagbalance ha?
Sodium nitrate and aluminum hydroxide.
Okay, we have the sodium nitrate. Now, diri sa pag-form sa products po dapat kabalot ta sa solubility rules. So, unsa man ni?
Yeah,
Sodium
aqueous,
nitrate. Aqueous ba ni? Is this
Aqueous.
soluble? Yes,
Yes,
kung
ma'am.
soluble
Aqueous.
gani. Okay, so balik ta sa solubility rules. So, kung soluble, we are going to write AQ, no? Sodium bitbia, which is an alkaline metal, no? Kung naay alkaline metal, mahimigid siyang soluble. Okay. What is the other product?
Aluminum hydroxide. ma'am.
Aluminum
Aluminum
hydroxide.
hydroxide.
Okay. Tanawa daw balik ang kuan? Tanawa daw balik ang sa solubility rules, ang aluminum, ang hydroxide, unsa man siya? Soluble, insoluble.
Soluble.
Insoluble.
Soluble.
Tato pa, this is our
Solid.
precipitate. Yes, atong solid. Now, after writing correctly the formulas of our compounds, and after identifying them, kung aqueous ba sila, meaning part ba sila sa solution, kung soluble gani, so they are part of the solution. Okay? So muna, butangan nato silang subscript nga AQ. If not soluble, so sila mo i-precipitate nato. So we're going to write S, which means they are solid. Okay. So pagkaman ana, that's the time for us to balance our equation. So let us write first. Yes, Janry. Ma'am Janry, are you raising your hand?
No, actually, it's okay. Already okay.
Ay,
ma'am.
sir, sorry.
It's okay, ma'am.
Nakay question, sir?
No clarification.
Sige. So okay na?
Yes, ma'am. Yes, ma'am.
Okay. Sige. So after Anna, let us write the elements involved, no? The elements which are found on both sides of the reaction para atong mabalance, no? Okay. Siguro most of you are teaching junior high and senior high school students. So kung mahimo kanang ma-discuss gyud nato sila in detail. Okay? Especially sa balancing, maglibog sila sa balancing, no? So, pwede nato itagsa-tagsa natog sulat. Na and then hydrogen. So, on the reactant side, we have 1 atom of aluminum. Nitrogen is 3. Oxygen is, this is 9 plus 1, so 10. Sodium 1, hydrogen 1. On the product side, 1 atom of aluminum. Nitrogen is 1. Oxygen, this is 3 plus 3, 6. Sodium 1, then hydrogen 3. Okay. So, unsa may atong iunang balance ani? If we're going to balance nitrogen first, so we're going to write here 3. Nitrogen diri sa reactant kay 3 man. So para mahimong 3 sa product, butangan natog 3 ang sodium nitrate where nitrogen is part of it. So by writing 3 there, sodium becomes 3, nitrogen becomes 3, our oxygen is 9 plus 3, and that is 12. Tama ba?
Yes po.
Yes.
Okay. So, na-change ang ato ang sa reactant side na-utro ang oxygen, no?
Yes.
And sodium and hydrogen. So kung butangan po nato ni diri og 3, sodium becomes 3, oxygen is 3 plus 9 equals 12. hydrogen is 3. Okay. So balance na, no? Balance na ba? Okay.
Yes,
So ito
ma'am.
sa ni-erase ha. Okay. And then we are going to write the ionic equation. So before writing the balanced ionic equation, ato sang i-identify unsa atong mga cations and anions. So we have aluminum ion. So Al plus 3, it's part of the solution. So we're going to write Aq plus NO3 negative 1
3.
Aq. The charge of nitrate is negative 1. Sodium is Na plus 1. So it's part of the solution. So we're going to write Aq plus hydroxide is OH negative 1, then Aq. For the products, we have Na plus 1 Aq plus NO3 negative 1 Aq plus the solid Al OH3. Morning. Okay. Then let's balance the equation. Okay. This is already balanced, no? Kining niya, balanced man na siya. So, for our ions, aluminum, 1 atom of aluminum in this mole, 1 mole of aluminum nitrate, there is 1 atom of aluminum. So we're going to write, pwede nato isulat ang 1, pwede po nato dili isulat ang 1. For nitrates, there are 3 moles of nitrate ions in 1 mole of aluminum nitrate. So 1 times 3, that's 3. 3. Sodium is 3. Hydroxide is 3. Okay? Tama ba? Then here we have 3 and then 3. Okay. Then cancel out the spectator ions. So cancel. Cancel. Okay. Write the ions left after cancellation of the spectator ions. So we have Al plus 3 aqueous plus 3 OH negative aqueous. The product side is Al OH3 solid. Okay. Okay, do you understand? Do you understand, class?
Yes, ma'am.
Yes.
Okay. Sige. So let's proceed, no? So wala na questions regarding precipitation. So if there are no questions, let's proceed to the acid-base reaction. So this type of reaction also occurs in aqueous reaction. Before discussing what happened during acid-base reaction, let us describe first, or let us discuss first the properties of the acidic substances as well as the basic substances. So generally, acidic substances are having sour in taste, no? Like for example, the vinegar. The vinegar is sour. It's because of the presence of acetic acid. Citrus fruits also contain citric acid. Then cause color changes in plant dyes. no? And also in kaning kalimot ko sa pangalan. Sa kanya kasagara atong gigamit nga indicator.
Litmus.
Correct. That's what I mean. Okay, so for litmus paper, a red litmus paper, kung ihumol siya sa acid, it remains red. No, but a blue litmus paper turns into red, no, if dipped in kaning acidic substance. Then it reacts with acids react with certain metals to produce hydrogen gas, no, like for example, magnesium reacting with hydrochloric acid, it will produce hydrogen gas and magnesium chloride. No, so if an acid reacts with a metal, hydrogen gas is produced. This is the equation. So hydrochloric acid reacts with magnesium. It will produce magnesium chloride plus the evolution of gas. Have you tried dropping a magnesium ribbon in a hydrochloric acid? Nakatry na ba mo? Wala. So kung atong i-drop na to ang magnesium chloride i-drop na to ang magnesium ribbon dito sa hydrochloric acid, mag-produce din siya bubbles, no? Mag-produce siya bubbles.
And
So kanang
is
kanang
the
evolution.
action.
Ha? Yes, Ma'am Felmi.
Yes po, ma'am. It's okay po.
Okay. So kanang bubbles nga ma-form na diha ang hydrogen gas.
Yes.
Okay, react with carbonates and bicarbonates to produce carbon dioxide. And then, so this is the equation. If a hydrochloric acid reacts with calcium carbonate, it will produce calcium chloride and carbon dioxide and liquid water. So one of the products is carbon dioxide. Okay. Aqueous acid solutions can conduct electricity. Like hydrochloric acid, di ba sa ako nag-iingon ganina, the strong electrolytes are strong acids, strong bases, and ionic compounds. And the hydrochloric acid is one of the strong acids. Okay, so if in aqueous solution, a hydrochloric acid, which is a strong acid, will dissociate into ions. So it can conduct electricity. Okay, so for basic substances, they have a bitter taste, no? Kana atong sabon, malagsikan ta sa sabon, mura siyag pait-pait nga muraga pamaak ang iyahang taste, no? It's because of the presence of a strong base, which is the sodium hydroxide, no? NaOH. Okay, it feels slippery, ang sabon danlog, no? Tungod sa base. So many soaps contain bases. Cause color changes in plant dyes. Okay, and for litmus paper, blue litmus paper remains blue in basic substances, and red litmus paper turns blue in basic substances. So aqueous-based solutions conduct electricity. Nganong mo conduct man siya electricity? It's because this is true only for strong bases. Okay, strong bases lang like sodium hydroxide, lithium hydroxide, these are strong bases, di ba? Sa ako nag-iingon ka ganina, the strong electrolytes are strong strong acids, strong bases, and ionic compounds. So mga strong bases will ionize also completely in water, so they can conduct electricity. Okay. Now, there are scientists who describe acids and bases, no? And one of those is Arrhenius, is Svante Arrhenius. So the kangatag og definition sila Bronsted, no? Sila Lewis, the Arrhenius, no? So let us know first the definition of acid given by Arrhenius, Svante Arrhenius. According to Arrhenius, an acid is a substance that produces hydrogen ion or hydronium ion in water. No? Muna yung definition ni Svante Arrhenius of an acid. It is a substance that produces hydrogen ion or hydronium ion. H plus is hydrogen ion. H3O plus is hydronium ion. Okay? Pareho ra na silag meaning. No? So, when an acid is dissolved in water, it will produce hydrogen ion or hydronium ion in water. Okay? For Arrhenius base, according to Svante Arrhenius, as a base is a substance that when dissolved in water will produce hydroxide ion. Okay, ma-produce na siya hydroxide ion. Now, take note that kining definition ni Svante Arrhenius sa acid and base, this is true for strong acids and strong bases. No? Okay, so you look at this equation. So hydrochloric acid, for example, which is a strong acid, when dissolved in water, will produce hydronium ion and chloride ion. Okay. So the presence daw of this hydronium ion indicates that hydrochloric acid is an acid according to Arrhenius' definition of an acid. For Arrhenius base, like yung example is ammonia, dissolved in water will produce hydroxide ion and ammonium ion. So anong na-form ni si ammonium ion? It is because ang hydrogen ion from water bonds with ammonia, forming ammonium ion. Okay, so this is the hydronium ion or hydrated proton, no? So hydrated proton, nga naman, ang hydrogen ion or ang water, no, di ba? Water is H2O. Okay? Dayon, ang hydrogen coming from hydrochloric acid is bonded to water. So, nadugangan ang hydrogen og isa. So, this becomes H3O. Dayon, na-charge kay sobra naman ang proton. Okay, so H3O plus. So we call this as hydronium ion or hydrated proton. Okay. Okay, so another scientist who gave a definition of an acid and base is Bronsted, no? So ang iyang acid is called Bronsted acid. According to him, a Bronsted acid or an acid is a substance that donates a proton. Ang gimin aning proton mo na ang H plus. Okay, ang gimin ana nga proton is the H plus. So it is a substance that donates a proton. So mooy mohatag sa hydrogen. Okay? So like for example, in the reaction between ammonia and water. Now ammonia is a weak base. Now here, si water, siya lang man ang naay hydrogen ion. Okay, water is formed from hydrogen ion and OH ion. Oh, di ba? So this hydrogen ion will bond to ammonia. Okay, mo-bond siya ni ammonia, forming ammonium. So ang nabili na lang is the OH. So here in the products are ammonium ion and hydroxide ion. So kinsa ang mihatag sa hydrogen? Kinsa ang mihatag sa hydrogen? It is water. Okay? So water donates the proton. Kaya siya ang mihatag sa hydrogen. Dito niya gihatag kang ammonia. Okay? And Bronsted defines a base as a substance that accepts a proton. So kinsa mi accept sa proton? Si ammonia. Therefore, ammonia is our base. Ammonia is our base. And water is our acid. Okay? No? So lain-lain sila og definition, si Arrhenius og si Bronsted. So according to Bronsted, an acid is a substance that donates a proton, while a base is a substance that accepts a proton. Since in this reaction, the acid donates a proton, a hydrogen ion to ammonia. So water is our Bronsted acid. This is Bronsted acid. And ammonia is our Bronsted base. Okay. Now, so after ammonia accepts the proton of water, si ammonia nahimong acid. But we call this as conjugate acid. Okay. We call this as conjugate acid. Conjugate acid. Si water, after donating a proton, OH na lang ang nabilin sa iya. So, gitawag po nato siya base, but a conjugate base. Conjugate base. Okay. So, ammonia and ammonium is called conjugate. They are called conjugate acid base, conjugate acid base pair. Okay. And water and hydroxide ion is also another conjugate acid base pair. Okay? Do you understand, class? Hello?
Yes po.
Yes, ma'am.
Yes po, ma'am.
Thank you. Let's continue. Ay. Ako, kuan man day ko dire. So, ammonia is our base, water is our acid. But when water donates a proton to ammonia, ammonium becomes an acid. Pero, ang tawag sa iya is conjugate acid. And our hydroxide ion is conjugate base. Then, the ammonia and ammonium, this pair is called conjugate acid base pair. And water and hydroxide is also called conjugate acid base pair. Okay. Ako saan i-erase, ha? Okay. So, we have some acids contain only one ionizable hydrogen ion. No? Ang ubang acids, naa sila'y isa lang ka hydrogen ion. Ang ubang pong acids contain 2 ionizable hydrogen ions. Others also contain 3. Okay? So, for example, mono, the prefix mono means 1. As what I have said, monoprotic acids are acids which contain only one ionizable hydrogen ion. Okay, for example, in this compound HCl, there is only one hydrogen that is to be ionized. So when hydrochloric acid is ionized, dissolved in water, when hydrogen chloride is dissolved in water, it becomes an acid, forming hydrogen ion and chloride ion. So there is only one ionizable hydrogen ion. So this acid is called a monoprotic acid. Okay, so a hydrochloric acid is a strong electrolyte because it is a strong acid. Another example is the nitric acid. When dissolved in water, this is hydrogen nitrate. When dissolved in water, it becomes an acid, no? Forming hydrogen ion and nitrate ion. So as you can see, isa lang po gihapon ang iyahang ionizable hydrogen ion. This is also a strong electrolyte. This is one of the strong electrolytes. Therefore, it is a strong acid. Acetic acid, tanawa ang iyahang reaction. It is a reversible reaction. No, it is a reversible reaction. Although this is a weak acid, it's a weak acid, so weak electrolyte siya. But it also has one ionizable hydrogen ion. So, unsa lang man ang ma-ionize sa iya, ha? This one, kana ang ma-ionize sa iya. So, when acetic acid is ionized, it will produce, okay, 1 mole of hydrogen ion and the acetate ion. Now, for diprotic acids, diprotic, the prefix di means 2, which means that the acid has 2 ionizable hydrogen ions. Okay, for example, H2SO4, or this is sulfuric acid. So, pwede siya ikaduha mo ionize because it has 2 hydrogen ions. By the way, kining hydrogen nga naa diri sa iya, dili na siya maapil og ionize, ha? Kini lang ang pwede ma-ionize. Okay? So when this sulfuric acid undergoes ionization, isa sa ang ma-remove sa iya, ha? Okay? So kini isa ka hydrogen ion ang ma-remove, so ang mabilin is this is hydrogen sulfate. Hydrogen sulfate ion. Okay. So, sulfuric acid is also a strong electrolyte because it is a strong acid. And then when hydrogen sulfate is ionized, kay napay isa ka hydrogen ang pwede ma-ionize sa iya, ha, napay isa na bilin. So, when this is ionized, it will produce hydrogen ion and the sulfate ion. Okay? Now this time, hydrogen sulfate ion is a weak electrolyte because it is a weak acid. For triprotic acids, these are acids containing 3 ionizable hydrogen ions, no? For example, the H3PO4 or phosphoric acid. So this is a weak acid, and as you can see, the reaction is reversible. So this is an indication, no, na the acid is weak kung naa siya two or double arrows, no, in opposite direction. So this is a weak acid because it is so this is a weak electrolyte. Okay. Now, di ba na-ionize ang isa ka hydrogen sa iya? Ang nabilin is duha na lang ka hydrogen atoms, and we call this dihydrogen phosphate, or another name for this is biphosphate, no? Dihydrogen phosphate or biphosphate. So in biphosphate or dihydrogen phosphate, naapay nabilin nga 2 ionizable hydrogen ions. So if one of the hydrogen ions is ionized from this, ang mabilin is hydrogen phosphate or HPO4 negative 2. Now this is also a weak acid, therefore it is a weak electrolyte. And then from hydrogen phosphate, naapagyapoy nabilin nga isa ka hydrogen that can be ionized. So if this hydrogen is ionized, it will form the phosphate ion, no? So ang sa product nato, hydrogen ion and phosphate ion. Now this is also a weak acid, therefore it is a weak electrolyte. Okay? So again, monoprotic acids are acids containing 1 ionizable hydrogen ion. Diprotic acids are acids containing 2 ionizable hydrogen ions. And triprotic acids are acids containing 3 ionizable hydrogen ions. Okay. Let's erase. Okay. Identify each of the following species as a Bronsted acid, a Bronsted base, or both. Okay, what's your answer for letter A? Is it a Bronsted acid, a Bronsted base, or both? Who would like to answer? Who would like to answer? Sir January. Hello, Sir January. You're still raising your hand. Do you want to answer? Are you still there, Sir January?
Sorry, ma'am. Actually, that was a while ago, ma'am.
Sige. Since I have seen you raising your hand, so I want you to answer letter A. Sige. Sir January, the first compound given is hydrogen iodide, or let's say kung aqueous na siya, that's hydroiodic acid. Is it
Yes,
a
ma'am.
Bronsted acid, a Bronsted base, or both an acid or a base and a base?
Yes, ma'am. Since iodic acid is an acid, ma'am, it can actually donate a proton from
Mhm.
this one. So this is considered as a Bronsted acid, ma'am.
Okay, correct. No? So it is a Bronsted acid. It is called hydroiodic acid. Okay, hydroiodic acid. How about letter B? Who would like to answer? CH3COO negative is acetate ion. Sige. Ma'am Analea. Sir January, kindly unclick the hand icon since you are through answering.
Okay, ma'am. Okay, ma'am.
Sige, Ma'am Analea.
Acetate ion, ma'am, is a Bronsted base because it has the tendency to accept a proton.
Correct. Okay. How about letter C? Anybody who would like to answer letter C? Analea, palihog ko og unclick sa imuhang kuan, Ma'am Analea. Okay, kinsay gusto mag-answer sa letter C? Walay gusto mo answer? Sige, magtawag ko og somebody to answer. Ma'am Michelle. Michelle Amor, Afable.
Yes, good morning, ma'am. Letter C, ma'am. I think it's also a Bronsted base.
Bronsted base. Do you agree to the answer of Ma'am Michelle? Why did you say it's Bronsted base, no? Imong giingon?
Because it will accept proton, ma'am. Because of its
Okay. Pwede pa siya ma-accept og proton. Unsa pa kaha ang laing answer? Sige, we'll call another one. Sir Jenry.
I think, ma'am, I think it's both Bronsted acid and base, ma'am, because we have still extra hydrogen that can, it's an weak electrolyte, ma'am. It can both accept a hydrogen ion or it can also like donate one more hydrogen ion.
Isa lang ba ang pwede pa niya ma-donate?
Actually, two, ma'am, two.
Pwede pa siya maka-donate og 2 kay napay nabili niya nga duha, no?
Yes, ma'am.
Okay, pero na siya i-charge nga negative, na siya
Negative.
available nga electron. So pwede pud siya modawat og proton.
Proton, yes, ma'am.
Okay, so it is both actually.
Both, yes.
Oo. Or we call it as amphoteric. No? Amphoteric siya. Kay it can act as both. It can act as a Bronsted acid or a Bronsted base. Okay? So do you understand?
yes po, ma'am.
Okay, let's continue. Okay. So for letter A, it's a Bronsted acid. And then letter B, it's a Bronsted base. And then letter C, it's a Bronsted acid and at the same time a Bronsted base. Okay. How about this one? Sige, who would like to answer letter A?
Bronsted acid.
Correct. It's a Bronsted acid because it has one ionizable hydrogen ion. Okay.
Yes.
Letter B. Oy, letter B na siya. Kanang san that's
NO2 minus.
nitrite ion. NO2 negative is nitrite ion. It is a Bronsted base. Okay. Na siya'y isa ka electron nga pwede pa mo bond sa isa ka proton. Okay, how about letter C?
Both, ma'am, Bronsted
Both.
acid base.
Okay, or amphoteric, no? Letter D,
Bronsted base.
Bronsted base. Okay, letter E is
Bronsted acid.
correct. Sige. Okay, now let's go to neutralization reaction. Excuse me for a while, ha? Sa oras na. Unsa na time sa inyo, ha?
9:45, ma'am.
Pwede mag-break sa tag 2 minutes. Panghihi sa ukadjut. Ha? Okay ra?
Yes, ma'am.
2 minutes lang. Sige, thank you. a weak acid and a strong base, like in the reaction of hydrocyanic acid. So this is aqueous hydrocyanic acid and aqueous sodium hydroxide, aqueous sodium cyanide, and water are formed. So since hydrocyanic acid is a weak acid, it does not ionize completely in water. So our ionic equation becomes HCN, or aqueous hydrocyanic acid, plus sodium ion plus hydroxide ion to yield sodium ion, cyanide ion, and water. So for our net ionic equation, cancel the spectator ions, sodium ion lang, no? So ang nabilin is hydrocyanic acid, hydrogen or hydroxide ion. Then sa right side, you have the cyanide ion and water. Okay, so only sodium ion is our spectator ion. Other examples of acid-base neutralization is the reaction between hydrofluoric acid. This is also a weak acid, and a strong base, potassium hydroxide. So here the products are potassium fluoride and water. Sulfuric acid is a strong acid reacting with a strong base, so it will also produce sodium sulfate and water. Nitric acid, which is a strong acid, ammonia as a weak base. This will form ammonium nitrate. So the last equation looks different because it does not show water as a product. However, if we express ammonia as ammonium ion, and if we express ammonia as ammonium ion and hydroxide ion, then our equation becomes this one, no? Nitric acid plus ammonium plus hydroxide ion to yield ammonium nitrate and water. Okay. Okay. Now let's go to oxidation reduction reaction. So if we say oxidation reduction reaction, this involves the transfer of electrons. Okay, transfer of electrons from one atom to another atom. So this is also called electron transfer reaction. So like for example, magnesium, okay, a magnesium here, si magnesium, if the electrons of, diba, magnesium is part of group 2A, no? And it is capable of losing 2 electrons. So if magnesium loses 2 electrons, it becomes Mg plus 2, right? Diba? If magnesium atom loses 2 electrons, mahimo siyang Mg plus 2. Diba? Kaya mihatag man siya 2 electrons because magnesium is capable of losing 2 electrons. Kaya nabilong siya sa group 2A. Ang ihang outer shell has, the outer shell of magnesium has 2 electrons. No, in a neutral atom, magnesium has 12 electrons and 12 protons. Sa iyang outermost energy level, it has 2 electrons. Now, magnesium prefers to lose these 2 outermost electrons than accepting 6 more electrons from other atoms. Kay mas dako ang energy nga makonsume niya kung mudawat siya 6 electrons from other atoms. So it has the ability to lose 2 electrons. And by losing 2 electrons, magnesium becomes positive 2. Do you understand?
Yes.
Okay. So if there are 2 moles of magnesium, if there are 2 moles of magnesium atoms, if each mole loses 2 electrons, no? If each mole loses 2 electrons, so kung duha ka moles, pila ang na-lose tanan?
4, ma'am.
4 electrons. Okay, so the charge here
4.
is positive 4. Diba? The charge here is positive 4. The total charge here in the 2 moles of magnesium. Because the 2 moles of magnesium loses 4 electrons. Kay each mole, the 2 moles of magnesium lose 4 electrons. Kay each mole loses 2 electrons. Okay. So this type of redox reaction is this half reaction, no? There are 2 half reactions of a redox reaction. There is what we call oxidation reaction, and the other one is reduction reaction. So in oxidation reaction, the atom loses electron. Okay? The atom loses electron. So this is oxidation reaction. Okay. In the case of oxygen atom, for oxygen atom, like here, oxygen gas, oxygen belongs to group 6, group 6A, and it has the ability to accept 2 electrons in order to become stable, no? Para mahimo siyang stable. So if there are 2 atoms, of oxygen and each atom accepts 2 electrons, so this oxygen molecule will accept 4 more electrons. Kay each atom accepts 2 electrons. Since duha man ni ka atoms, so 4 electrons ang iyahang ma-accept. Okay? So as you can see, in the right side of the arrow, there are 2 moles of oxygen atom, and each atom accepts 2 electrons. That's why the charge is negative 2. So if we're going to get the total of this is 2 times negative 2. So this is negative 4. Okay. Kini siya, may charge. So this is 0 and this is negative 4. So this is balanced. Okay, anong negative 4? This is 4 times the charge of electron, which is negative 1. So 4 and negative 1 is negative 4. Kini, 2 moles of oxygen with a charge of negative 2. So 2 times negative 2 is negative 4. Okay, this type of half reaction is called reduction reaction. Okay, reduction reaction or gaining of electron. Okay. Kung oxidation reaction, the acronym here is LEO. LEO LEO stands for losing electron is oxidation. And for reduction, the acronym that we can use is GER, not GER, huh? GER lang. Gaining electron is reduction. Okay. So if this is the reaction between magnesium and oxygen, okay, 2 moles of oxygen, 2 moles of magnesium react with 1 mole of oxygen gas to yield. Okay, so here, this is the redox reaction. No? So the charge here is 0. Okay, so 2 times 0 is 0. Then this is 0. Okay. Si oxygen, siya man ang ni-receive og 2 electrons of 2 electrons each atom. Since there are 2 atoms, so 4 electrons ang iyang na-receive tanan. Okay? This is combining, kung atong i-combine ang oxidation reaction and the reduction reaction, no? So kini ato silang gi-combine, all reactants are combined and all products are combined here. Okay, so sa product side, we have 2 Mg plus 2 plus 2 O negative 2 plus 4 electrons. Okay, so kung atong tanawon kung na-balance ba ang atong redox reaction, okay, tanaw nato kung na-balance ba. So this is 0. The charge here is 0. Wait, i-balance nato ang we are going to balance first with respect to the number of atoms. So with respect to the number of atoms, our magnesium is 2.
2.
Okay, 2 on the reactant side. Sa product side, there are 2 atoms also. For oxygen, this is 1 times 2. So 2 atoms. Sa product side, 2 times 1, 2 atoms. Sa left side, 4 electrons. Today, 4 electrons. Okay, so with respect to the number of atoms, the equation is balanced. Now, how about the charge? Okay, so here, walay charge si magnesium. So that is 2 times 0. So 0 charge. This one is 0. Kini siya 4 electrons. So negative 4. Okay, sa product side, we have 2 times positive 2. So this is positive 4. This one, 2 times negative 2 is negative 4. Okay, positive 4 and negative 4 is equal to 0. Okay, and this one is 4 electrons. So with respect to the charge, our equation also is balanced. So this is now our balanced equation. Okay. Excuse me, Ma'am Vestil. Hey, Vestil. Okay. Hello.
Yes, ma'am.
Yes.
Sige. So this equation is balanced, no? Sige. Okay. So there is what we call reducing agent and oxidizing agent. Wait lang ha. I wonder anong na ay 3 yung 4. Ako saan yung stop share. Budget lang kaayo ha. Ay. Okay, so the reducing agent is the substance that donates electron or electrons and causes the other substance to be reduced. while the oxidizing agent is the substance that accepts electron or electrons and causes the other substance to be oxidized. Okay, so we just have to remember also these acronyms. Kaganina, we have the LEO and JER. LEO stands for losing electron is oxidation, and JER is gaining electron is reduction. Oxidizing agent, we can also use these acronyms, these two acronyms. LEORA, which means losing electron is oxidation, and it is the reducing agent. For JEROA, gaining electron is reduction, and it is the oxidizing agent. The one that gains electron undergoes reaction, and it is the oxidizing agent. The one that loses electron undergoes oxidation, and it is also the reducing agent. Okay. In this equation, zinc reacts with copper 2 sulfate, aqueous copper 2 sulfate, to produce zinc sulfate and copper. So here, kung atong isulat, first is we need to determine which undergoes reduction and which undergoes oxidation. Okay, so for zinc, this is the half reaction of zinc. And sa iyang, kung tanaw nimo ang reactant, zinc is a free element, no? It does not react with other atoms. So it is a free element. But on the product side, si zinc, may bond na siya with the sulfate ion. Okay? So tungod kay nag-bond siya with the sulfate ion, zinc becomes positive 2. So zinc becomes positive 2 in the product side, but on the reactant side, this is 0. Kay free element man siya, it does not react, it does not bond with other elements. So, meaning, nahimo man siyang positive 2 sa product side, it means that it loses 2 electrons. Do you understand? It loses 2 electrons. So, by losing, for copper, you look at copper. On the react, forms a bond with the sulfate ion. Okay? So, here, copper here is positive 2. Anong positive 2 man si copper? Kung ato po din siyang i-ionize, remember that sulfate is negative 2. Sulfate is negative 2. Unya, si copper na may duha ka oxidation state si copper, positive 1 and positive 2. Pero nganong dili man ni positive 1? Why is this positive 2? Tanawon, kung imong tanawon ang ilang formula, walay subscript, no? Si copper has no subscript, si sulfate wala pa nakabutang nga subscript. It means that the same ang ilang subscript. So, kung kana ato nang i-criss-cross, panta na siya. That is Cu2 SO4. Oh. Pero kung pareho ra ang subscript, di ba? Ato mang ma-cancel. Okay? Cancel man na. So the correct formula is this, CuSO4. So meaning, Cu here is positive 2. If this is positive 1, no? If Cu here is positive 1, so kuan unta ang formula? That is Cu2, then SO4. Mo na ang formula. Pero dili man ni siya mao ang formula nga naa dinhi. CuSO4, which means nga na-cancel ang ilang subscript. Okay? So that's why we are able to say that copper here is positive 2 on the reactant side. Sa product side, copper does not react with other elements. Therefore, we call this copper as free element. And for free elements, the oxidation state is 0. Okay? So si copper sa reactant side, since yung charge is, yung charge is positive, meaning it loses electrons, no? Copper diri loses electrons. Positive 2 man, so it loses 2 electrons. Okay? Sige. So zinc here is oxidized. Ganong nag-oxidize si zinc because from 0 sa reactant nahimong positive 2 sa product. So nag-lose siyag electron. Sak nang giingon ganina, losing electron undergoes oxidation. So zinc is oxidized. Okay? And zinc is our reducing agent. From the acronym LEORA, losing electron undergoes oxidation, and it is our reducing agent. Okay. Now, copper in the reactant side is positive 2. Pag abot sa product, nahimo siyang 0. So what does it mean kung nahimo siyang 0? Sa reactant side, it is positive 2. Pag abot sa product side, it becomes a free element in which the charge is 0 charge. So it only means that copper here is gaining electrons. No? Ni-gain siyag electrons. Pila iyang gigain nga electrons? Duha. So after gaining electrons, so 2 plus 2 ang iyang charge. Naparisan og duha ka electrons kay may gain siya. So pag abot sa product, nahimo siyang 0. Okay? So copper gains electron. How many electrons? 2 electrons. So from the acronym GEROA, gaining of electron undergoes reduction. Okay? And it is also our oxidizing agent. Do you understand?
Yes, ma'am.
Okay. So copper wire reacts with silver nitrate to form silver metal. Nakuntay copper wire. Nag-react sa silver nitrate. Dayon, may form of silver metal. So this is the reaction, no? Copper wire reacts with silver nitrate, forming copper nitrate and releasing silver. So silver here is a free element. Okay. Now, so kung tan-aw na to atong i-analyze para mahibaw-an nato kinsang nag-undergo og reduction, kinsang nag-undergo og oxidation. In the reactant side, copper is a free element. Therefore, its charge is 0. Pag abot sa product side, copper is bonded to the nitrate ion, no? And here, based on the formula, copper is positive 2 because the subscript of nitrate is 2, which means that this is the magnitude of the charge of copper. So this is, copper here is positive 2. Okay, so Cu plus 2 or Cu positive 2 plus 2 electrons. Okay. Ion, copper 2 ion. Okay. Mi-lose siya og, diri sa react sa product side, mi-lose siya og electron. Okay. So, copper on the react, its oxidation state, or it has no charge, no? Pag abot sa product, nahimo siyang +2. So what does it mean? Imbis kay balance ang iyahang
Loss.
electrons and protons, pag abot diri kay hinglabaw na iyahang proton. It only means that it loses 2 electrons. Mihatag siya 2 electrons. So unsa man kani siya nga type of unsa man ni siya nga half reaction? It loses electron.
Oxidation.
Okay, therefore it undergoes oxidation reaction. Si silver, kung ato i-analyze sa reactant side, silver is bonded to the nitrate ion, no? So silver here is a charge particle. The charge of silver is +1. Unya tan-aw na to diri sa product nahimo siyang 0. So from being +1 to 0. Sa ato pa, kining niya naparisan siya isa ka electron mo na nahimong 0. So si silver di ay is accepting 1 electron. So pag abot sa product, the charge is 0. Okay? So here in silver accepts or gains electron. Dere si copper loses electron. Mo na nahimo siyang charge particle. Okay? So since silver gains or accepts electron, it is reduced, meaning it undergoes reduction. And it is deoxidizing, causes copper to oxidize. That's why it is deoxidizing agent. Si copper is losing electron. Copper is losing electron, therefore, copper undergoes oxidation. Nag-undergo siya of oxidation, pero it also causes silver to reduce. So copper is our reducing agent. Do you understand?
Yes,
Tan?
yes po.
Okay,
Yes, ma'am.
thank you. Sige. So, the concept on oxidation number is very important, no? Importante kaayo nga ma-master nato ang oxidation number. Kay that concept is very useful in oxidation reduction reaction. So if we say oxidation number, it is the charge the atom would have in a molecule or in an ionic compound if electrons were completely transferred. Okay? So ang charge ko no nga mahimo sa atom, kung mahimo siya sa atom in a molecule, no? If the electron or if electrons were completely transferred. Okay. So remember that free elements have an oxidation number of 0. Kadjut lang ha. Ako sa ning ipang-delete ning kung anong na yung mga numbers. Kadjut lang yun. Okay, so let's continue. No, for free elements, they have an oxidation number of 0. So, unsa man yung mga free elements? These are elements in the uncombined state, meaning wala silang may bond with other atoms. Okay, like for example, sodium, beryllium, potassium, lead, hydrogen gas, oxygen gas, white phosphorus or P4, kung dili ni sila mo bond with other atoms, their charge or their oxidation number is equal to 0. Okay. For monatomic ions, the oxidation number is equal to the charge on the ion. Okay? Kung unsa ang ilang charge as an ion, that is also their oxidation number. For example, Li plus, no? Li plus, lithium ion. This is the charge. The charge of lithium ion is +1 here. Okay, +1 in iyang charge. That charge of the ion is also the oxidation number of lithium. For iron 3 ion, its oxidation number is +3. For O -2, okay, the charge of oxygen here is -2. This is a superoxide, no? For superoxides, the charge is -2, which means that its oxidation number is, okay, -2. Wait, this is not a superoxide. This is oxide, not superoxide. Oxide ra siya. So, ang iyang charge -2 man, so ang iyang oxidation number is also -2. Okay. The oxidation number of oxygen is usually -2. But if oxygen is a peroxide, like for example in hydrogen peroxide, H2PO2, hydrogen here is a peroxide. So, ang iyang ion, kung i-separate na, kung atong i-ionize, it is H2 negative, no? So, ang iyang charge, ang iyang oxidation number here is -1. If oxygen is not a peroxide, its oxidation state is -2. Pero kung mahimo siyang peroxide, like in hydrogen peroxide, its oxidation number is -1. Okay, number 4. The oxidation number of hydrogen is +1. Except when it is bonded to metals in binary compounds. No? In these cases, its oxidation number is -1. So for example, sodium hydride. Sodium hydride. Okay. Hydrogen here takes the +1 charge. No? No, negative, I'm sorry. Kasi sodium is a metal. So sodium here is +1, while hydrogen is -1. Okay, but if hydrogen is bonded to a non-metal, like in hydrogen chloride, hydrogen takes the +1 charge because chlorine is -1. Okay, you understand? So si hydrogen, mahimo lang siyang -1 if it bonds with a metal. Okay, saan i-erase ha? Okay. For group 1A metals, mga group 1A, alkali metals, they are, their oxidation state is +1. For group 2A, +2. Fluorine belongs to group 7A, so its oxidation number is -1. The sum of oxidation numbers of all the atoms in a molecule or ion is equal to the charge on the molecule or ion. No? The sum of the oxidation numbers of all the atoms in a molecule or ion is equal to the charge on the molecule or ion. Oxidation numbers do not have to be integers. Oxidation number of oxygen in the superoxide ion O2 negative is -1/2. Okay? Pero only few compounds are formed by the superoxide. So we will not deal more with the superoxides, no? Ang ato lang gamiton, ang ako lang ihatag sa inyo ng mga compounds of oxygen are katong common. No? Okay, only few are superoxides. Okay, so for example, erase. For example, oxidation, what is the oxidation number of all the elements in, this is hydrogen carbonate, no? This is hydrogen carbonate. Unsa ko na yung mga oxidation numbers of all the elements in hydrogen carbonate. So, meaning, unsay oxidation number ni hydrogen, carbon, and oxygen. Okay. So, in hydrogen carbonate, oxygen is -2 because oxygen here is not a peroxide. So, if oxygen is not a peroxide, the compound of oxygen, or the oxidation number of oxygen is -2. For hydrogen, it is +1. So carbon, to determine the oxidation state of carbon, we have, okay, nga nahiabot man ta ana. Okay, so di ba, kabalutan ni hydrogen, let's start with hydrogen. Hydrogen is, there is 1 atom of hydrogen times, pilay charge ni hydrogen? +1.
+1.
Okay, plus, wala ta kabalo sa charge or sa oxidation state ni carbon, times 1 atom of carbon, plus 3 atoms of oxygen, times the charge of oxygen in this compound is -2. And what is the overall charge? The overall charge is -1. Okay. So this is 1 plus Cu times carbon, C times 1. Wait. Shoot lang ha, nasayop ko. Okay, so 1 times +1, this is 1 plus C times 1 is C. Then +3 times 2 is -6 equals -1. So we are looking for the oxidation state of carbon. So just transpose carbon is equal to, that is -1 plus 6 minus 1. So pila man na. So carbon here is +4. Okay. So carbon dioxide is +4. Then hydrogen is -2. And oxygen is -2 and hydrogen is +1. Okay. So these are the charges of some of the elements in the periodic table, no? So as you can see, all group 1 elements, the oxidation state is 1, tanan nga group 2A, +2, group 1A, +1, then group 3A, +3, no? Dayon, varied na dayon din he. For varied na dayon ang uban, especially the elements, the transition elements, no? Pero ang uban sa ila, sa transition elements, they have only 1 oxidation number. Yes, Michelle, you're raising your hand.
Hi,
Ma'am
ma'am.
Michelle?
Good morning, ma'am. Excuse me.
Morning.
Ma'am. We have another class, ma'am, 10:30.
10:30 na? Hala, I'm sorry.
Yes, ma'am.
Okay, sige, sige. So, we will just continue with our discussion next meeting. No, Dayon, kindly answer, check your understanding 1, 2, 3. It's there in the use step. Okay, wala na akong mabantay ang oras. Sorry kaayo. Sige. So, goodbye everyone.
Bye, ma'am.
Bye.
Goodbye. See you next
Thank
time.
Bye, ma'am. Goodbye. Okay, ma'am. Thank you.
Goodbye. Thank you for
Thank you,
joining.
ma'am.
Thank you, ma'am. Thank you.
Goodbye.
Thank
Okay.
you very much.